Hey everyone, and welcome to this explainer. So, today we're diving into a career path that is literally transforming how we think about our food and honestly, our entire future. Now, if you're like me and you thought agriculture was just about, traditional manual farming, you are in for a huge surprise. We're looking at B.Tech Agricultural Engineering. It's this incredibly high-tech, highly lucrative engineering discipline that is right at the bleeding edge of solving massive global challenges like food security and climate change. So let me ask you a quick question. Do you want an engineering career that actually helps save the planet? We're going to explore how modern agricultural engineers aren't just sitting in an office. They're out there piloting drones, designing AI-powered robotic harvesters, and building real climate-resilient systems. It's essentially taking the most cutting-edge technology out there and applying it to our most basic human need.
All right, here's our quick roadmap for today's explainer. We're going to cover the smart farming revolution, break down the difference between engineering and agriculture science, walk through admissions, look at the actual syllabus, compare government and private sector jobs, and finally, dive into those salaries and global opportunities.
Okay, let's jump right into part one, the smart farming revolution, focusing on drones, AI, and climate action.
Look, it's no secret that climate change, erratic rainfall, and depleting groundwater have created an absolute crisis. We urgently need sustainable agriculture. And the sheer scale of the solution required is massive. Take the Indian government's SMAM initiative, for example. They've set an aggressive target to push farm mechanization from its current 47% all the way up to 75% by 2030. Think about that jump. What that translates to in the real world is a massive, immediate demand for engineers who can actually design, manufacture, and maintain all this brand new machinery.
Moving on to Section 2, Engineering versus Agriculture Science. What exactly is the difference? Now this right here is a huge point of confusion for students and parents trying to decide on a degree. Both of these paths focus on farming, sure, but they lead to completely different daily lives. A B.Sc in agriculture is heavily rooted in biology and agronomy. That's your PCB focus, physics, chemistry, biology. It's ideal if you love biological sciences and want to do field management. But a B.Tech, that is hardcore engineering. It requires that PCM background, physics, chemistry, and math. Instead of studying the crops themselves, you're the one designing the tractors, the AI-driven irrigation systems, and all the tech infrastructure that actually grows those crops.
All right, Section 3, Admissions and Entrance Exams. Let's talk about your pathway in.
If you're a high school science student right now and you're stressing about getting a seat, take a deep breath. The admission process is honestly incredibly manageable. Step 1, you just need your 10+2 with physics, chemistry, and math, usually sitting around 50% marks. Step 2 is tackling the right entrance exams. Then, Step 3 is the counseling process, through bodies like JOSA or ICAR, where you rank your preferences. And finally, Step 4, you get your college allotment. It's your standard engineering track, but it leads to a uniquely rewarding career.
So what specific exams should you be targeting? Well, to get into premier institutes like IIT Kharagpur, you're definitely aiming for JEE Main and Advanced. But here's the cool part, look at the variety. Since 2022, the CUET UG exam has become this golden ticket for getting into ICAR-affiliated agricultural universities, places like Punjab Agricultural University. Plus, there are some fantastic state-level exams out there too, like MHCTAT in Maharashtra, APEM-CET, and BCECE in Bihar. So you've got multiple solid pathways to get yourself into a top-tier college.
Let's roll into Section 4, your tech-driven syllabus. What are you actually going to study? I want to be super clear here. This is not just sitting in a lecture hall learning theory. This is a highly specialized, hands-on degree with real lab and field testing. In your second year, you're laying down the core foundation with subjects like thermodynamics, fluid mechanics, and farm machinery. By third year, you're diving headfirst into hardcore machine design, tractor systems, and renewable energy. But man, look at the fourth year. That's where you get into the truly cutting-edge stuff. We're talking precision agriculture, artificial intelligence, and utilizing satellite data through GIS and remote sensing. You are literally going to learn how to pilot drones and build smart robotic systems for crops. How cool is that?
Moving to Section 5, Government versus Private Jobs, and the massive industry demand we're seeing right now.
Thanks to all those climate challenges and this huge wave of tech integration, employers are basically scrambling for tech-savvy graduates. On the government side, you've got these incredibly stable, high-impact roles. You could become a scientist at ICAR, an officer at NABARD, or even aim for the super-prestigious Indian Forest Service. But then on the private sector side, it is incredibly lucrative and heavily machinery-driven. Industry heavyweights, think Mahindra, John Deere, Nestle, Jain Irrigation, they are constantly recruiting engineers to design new equipment, optimize food processing, and innovate the way we do irrigation.
And honestly, we absolutely cannot talk about jobs without talking about the agri-tech startup boom. Just in India, there are over 3,000 agri-tech startups operating right now, and they are backed by more than $3 billion in funding. Companies like Dehat, Cropin, and NinjaCart are in this fierce competition for engineers who actually understand both farming and advanced technology. Listen, if you can combine your B.Tech degree with skills in programming, the Internet of Things, or data analytics, you're going to be so heavily sought after to build things like AI pest detection systems or blockchain supply chains. It's a goldmine.
Which brings us perfectly to Section 6, Salaries and Global Opportunities. Let's talk about the money.
It's obviously crucial to understand the financial expectations when picking a degree, so let's look at the average salary trajectory. As a fresher in India, you're generally looking at a starting package between 3.5 to 7 lakhs per annum. But here's the kicker. Jump to that mid to senior level just 5 to 7 years in, and you're suddenly looking at 10 to 20 lakhs, or even more. And remember that startup boom we just talked about? If you combine this core degree with high-demand skills like data science or drone tech, you're going to place yourself right at the absolute highest end of that spectrum.
Now, take a look at this massive number. $170,000. That is the top-end international salary for senior engineering project managers over in the US. And it is definitely not just the United States. Over in Europe, Italy is offering extremely lucrative salaries, upwards of 90,000 euros for top experts in sustainable water management and agricultural automation. The takeaway here, the world pays a serious premium for these specialized skills.
So where exactly are these overseas jobs? Well, the U.S. is aggressively recruiting people for precision farming and automation to meet strict climate regulations. Italy, as I mentioned, is a major hub desperately looking for engineers to solve severe water management challenges using smart tech. You've got Germany and the Netherlands, which are just absolute powerhouses for agribusiness. And then Australia and Canada are constantly on the hunt for experts in food technology and sustainable farming. The skills you pick up in this degree are totally borderless.
I really love this quote because it hits the nail right on the head. B.Tech Agricultural Engineering is far more than a traditional farming degree. It sits at the intersection of core engineering, sustainability, and emerging technologies like IoT, drones, and AI. It perfectly summarizes the true essence of this path. It's a career that quite literally builds the future.
So, that brings us to our final and most important question. Are you ready to engineer the future of our planet? If you're a student looking for a career that pays incredibly well, offers true global mobility, and actually tackles the most critical existential challenges facing humanity today, this might just be the exact degree for you. I really hope this explainer has sparked your curiosity and given you a super clear roadmap of what to expect. Thank you so much for joining me today and keep learning.